Assalamualaikum, and today we'll be discussing about the important factors for the sustainable future of petrochemicals and its product and supplies in Malaysia. Petrochemical manufacturing has a substantial environmental impact and is critical to guarantee that the industry is sustainable. The International Energy Agency conduct research on perspective option for producing petrochemical goods in a more sustainable manner. The study examined the impact of a mixture of industrial factors on the history, current, and future status of the petrochemical industry with an emphasis on methanol, olefin, and ammonia. There are three petrochemical companies in Malaysia, which is Petronas Chemicals Group Berhad, Petrochemical Malaysia Sendirian Berhad, and lastly Pengerat Refining and Petrochemical. In this figure from the ICIS report, Malaysia import for MTBE in 2019. There are one sub-company that has been identified, which is the urban industrial area. Pahang state government was eager to develop a petrochemical hub on the east coast in Gabang. Air Quality Act require the discovery of alternative to lead as an octane booster. Petronas Joint Venture Corporation founded in March 1989. PKNP has played a vital role in encouraging investors to invest by engaging and communicating effectively with investor or stakeholder, resulting a problem or issue encountered by investor, play its role in coordinating with local authorities and agency in ensuring adequate infrastructure and
Apa lagi tak
utilities.
nampak?
PKNP has played a
Hello, Assalamualaikum and hi. My name is Nur Adli Zafri bin Zanizam and I will discuss the application of MTBE in industry and the example of the company. The first application of the MTBE is gasoline blending for higher RON grade gasoline. MTBE has a high octane rating and when blended with gasoline, it improves the overall octane level of the fuel. This is crucial for high performance engines and help in optimizing combustions, reducing engine knocking, and improving fuel efficiency. The example of the companies such as Petronas and Shell. Next, manufacturing of electronic displays. MTBE can be involved in the synthesis of polymers like polymethyl metacyclate, which is used in the manufacturing of transparent materials, including screens for electronic devices. Samsung is one of the examples. Next, synthetic rubber tire manufacturing within automotive industry. MTBE may be involved in the polymerization processes for producing synthetic rubber, contributing to the creation of materials used in tire manufacturing. An example of the company is Michelin. We go next with applications number 4, which is fragrances and flavor compositions. MTBE's solvency properties make it suitable for carrying and delivering aromatic compound, contributing to the formulation of fragrances and flavor used in various products such as pharmaceuticals, cosmetic, and consumer goods. An example of the company is Dior. Besides that, pharmaceutical also one of the application of MTBE. MTBE properties such as its solubility and low toxicity can make it suitable for specific pharmaceutical applications, either as a solvent or as part of the manufacturing process. Lastly, pentanol blending. MTBE ability to dissolve various substances make it useful in the formulation of pentanols, where it can help in achieving the desired consistency and performance. Next, we will go through with Memorandum of Understanding for MTBE. Since MOU of MTBE in Malaysia has been non-disclosure to the public yet, so we will discussing on MOU of MTBE in New Hampshire, United States. For the agreement, DES, or we call Development of Environmental Service, to implement mutually agreed upon programs to prevent exposure to MTBE by identifying and remediation contamination of groundwater in New Hampshire and providing safe, clean drinking water to those who have been affected. For the development of the project plan, it has 5 points. First, investigation and remediation of existing contamination sites. Second, testing at risk drinking water wells within a location radius of contamination source sites. Third, providing safe, clean drinking water to impacted citizens. Fourth, installation and improvement of public water supply infrastructure in areas having significant MTBE contamination. And then lastly, implementation of measures to prevent further MTBE contaminations. The plan must be approved by DOJ prior to implementation. For the scope of work, the barrier effort will include coordination of MTBE site cleanup, drinking water quality assessment, public and private drinking water supply improvement, and prevention work. For the payment, the OJ and DES should jointly determine the amount of funds that will be necessary to support the MTBE remediation program for the following biennium. Unless instructed otherwise by the governor or the legislature, the OJ will seek the approval of the fiscal committee and the governor and council to transfer the sum to DS by the beginning of the following fiscal years. For the reporting, on a quarterly basis, DS will provide a report to DOJ that will include the name of each project, the total amount spent, what the money was spent on, and a copy of its appropriation summary report. DOJ may audit DS expenditure.
There are three important factors for the sustainable features of methyl tertiary butyl ether, also known as MTBE. The first one is risk mitigation measure. Second one, water treatment technologies. And last one is monitoring and remediation. Risk mitigation measure is implementing strict guidelines and protocols to prevent spill, leaks, and groundwater contaminations during productions, transportations, and storage of MTBE. During productions, we need to follow the strict safety rules. This include checkings for risks, analyzing hazards, and using systems to contain any spills. Workers should be trained on these safety rules and how to respond in emergencies. In transportations, the packaging must be secure and leak-proof. People who move MTBE should be trained on how to handle it safely and what to do if there is a spill. For storage, the storage building must be strong and checked regularly. We should use real-time monitoring systems to quickly spot any leaks. We must always follow industry standards and have regular checks to find and fix any risks quickly. We should also have emergency plans that are updated and practiced regularly. we, and for community engagement, we should talk to local people, authorities, and other interested parties about the safety measures and risks. We should also have plans in place for communicating with this group if something goes wrong. Developing and investing in water treatment technologies capable of efficiently removing MTBE from contaminated water sources is crucial to mitigate its impact on the environment and human health. Addressing MTBE contaminations in water resources required the development and investment in advanced water treatment technologies tailored specifically for its efficient removal. MTBE is highly soluble in water, making conventional treatment methods less effective. Advanced treatment technology such as advanced oxidation processes, as known as AOP, like UV photolysis or ozonations, have shown promise in breaking down MTBE molecules in water. Additionally, advanced filtration methods, including activated carbon filtrations or membrane-based separation techniques, can efficiently trap and remove MTBE contaminants from water. Bioremediations, employing specialized microorganisms capable of metabolizing MTBE, is another avenue under exploration for its potentials in degrading the compound in water sources. Research and investment in enhancing these technologies are essentials to optimize their effectiveness, scalability, and cost efficiency. Moreover, the developments of hybrid treatment systems that combine various techniques such as using AOPs in conjunction with filtrations can offer more comprehensive and efficient removal of MTBE. These innovative approaches must align with regulations and guidelines to ensure safe and environmentally sound treatment processes. Investing in the advancements and implementations of these water treatment technologies is crucial to safeguarding water resources and protecting human health from the potential adverse effects of MTBE contaminations. This effort contribute significantly to mitigating the environmental impacts of MTBE and ensuring the availability of clean and safe water sources for community and ecosystems. Implementing comprehensive monitoring program is critical to identifying and assessing MTBE contaminations in water sources. These programs involve systematic and regular sampling, employing sensitive detection methods to identify even trace amount of MTBE. Monitoring ensure early detections, enabling prompt interventions to contain and address contaminations before it spread extensively. Continuous monitoring is essential, especially in areas vulnerable to MTBE due to its mobility in groundwater. Once contamination is identified, effective remediation techniques are crucial to mitigate the impact. Remediation strategies vary based on the extent and nature of contaminants. In situ remediation methods involve treating the water at the source, utilizing techniques like pump and treat system with activated carbon filtrations or advanced oxidation processes to remove MTBE from the water. Ex situ remediation techniques may involve excavating contaminated soil or water and treating it off-site using specialized technologies. Bioremediations, leveraging microorganisms capable of degrading MTBE, is an emerging technique that shows promise in breaking down the compound in contaminated sites. In conclusions, the sustainable features of MTBE necessitates a comprehensive and multi-dimensional approach. Petrochemicals, including MTBE, play a crucial role in various industries, but their productions and uses pose environmental challenges. To address these challenges, it is imperative to implement rigorous risk mitigation measures encompassing guidelines and protocols to prevent spill, leaks, and groundwater contaminations throughout the entire life cycle of MTBE. Ultimately, achieving a sustainable futures for MTBE requiring collaborative efforts involving industry stakeholders, government bodies, and the community. By combining technological advancements, stringent safety measures, and proactive monitoring and remediation strategy, the industries can contribute to a more sustainable and environmentally friendly futures. Thank you. That's all for our group.